Hey, what's up guys? This is Prathamesh Patil from team OCF. I am new to reviewing computer related products. Today I am going to be reviewing ASUS Crosshair 5 Formula Z. This is the ROG motherboard, Republic of Gamers motherboard featuring the 990FX chipset. This board is basically meant for overclockers and the gamers. Basically these people usually buy these kind of high-end motherboards. These boards have really nice build quality and stay rock solid even on higher overclocks. So yeah, now what I am going to do is to show you the motherboard. Actually I cannot as if show you the board because it's in there and I don't have any backup rig of mine. So what I'll be doing is I'm going to stop the camera now and going to show you a look at the motherboard by showing an image. I'll zoom in and I'll show you all the parameters and all the components on the board so that you could have a good look at the motherboard. Go. Hello guys, I'm back. Now what I'm gonna do is, this is the Crosshair 5 Formula Z motherboard. It's an image. I'm going to zoom into this image and show you each and every component on it. So let's start from the top left corner. Here you can see is the standard 8-pin power connector for the CPU. Now this is the extra 4-pin for the power delivery to the CPU and the VRMs. This is basically to stabilize the power so that your CPU can be stable even at the higher overclocks. So to the right hand side there is a CPU fan header, CPU optional temp chassis fan, and yeah, you could see here this is the slow mode switch which you can toggle on or off. Basically what slow mode does is it slows down your CPU frequency so that even at higher overclocks, when you are at ridiculously higher overclocks, when you are running LN2 mode and all, so whenever you are going to be running more high frequencies, you could use this slow mode to just as if for a case you want to validate a CPU frequency of say 8 GHz. So obviously you are going to do it on LN2. So what you can do is just switch on the slow mode so that the CPU Z screen stays as long as you validate it. So yeah, and down to that, I don't know if you guys can see this, but this is the LN2 mode jumper. What basically this thing does is, whenever you have put the jumper on the first 2 pins, this LN2 mode is disabled, and whenever you put this to the second and the third pin, the LN2 mode is enabled. What basically you could see to the right is the LED debug poster. So it comes in handy for the overclockers to find out the fault or what is causing them or preventing them for booting up into the system. So yeah, then there you go, you have the start and reset switch and the go button. Now these features actually come in handy when you are using a test bench, so that basically whenever you are testing some motherboard or even any component on your test bench, so you don't need to hook up cables and all. So this feature actually is really very nice, so thumbs up for it. Fine. Go button or the memo K button, what it actually does is, whichever memory you throw at this board, whichever memory you hook in there, what it does is, it basically, if the unknown or the unsupported memory has been installed into that slot, in any slot or slots, multiple memories say, what go button does is it runs it at its native speed. Native speed means not the rated speed, but the speed which it has been meant to be excuse me, which is meant to be run on it. So basically, by pressing the go button, any unsupported memory can be installed and still you can boot up into your system. Okay, there you can see is another fan header. Then this is the 24-pin ATX standard power for the motherboard. Now here you can see are the probe points where you can basically it has a common ground, and what you can do is take the multimeter, take two probes from the multimeter, basically just keep one on a common ground and check the CPU voltage, CPU NB, that is the integrated memory controller voltage, VDDA, DRAM, north bridge, HT, south bridge, or whatever you want to test it. Obviously these many parameters can be tested on this board at least. So yeah, that's too good. Then again, this is the USB 3 front panel header. Again, these are the SATA ports. Now this board actually has 4x2, that is 8 SATA ports. So basically these 3 are natively supported by the chipset, but these two which are externally added are handled by the as media controller chip. Again, you have the iROG. This is a nice looking ROG logo over here, looks great. Then what you can see over here is DRCT, that is the direct key header, which actually I am using because the rig is in there, so the board is in, so I can't press the direct key now and then to get into the BIOS. What basically direct key or this header, by shorting this header, what it does is without pressing any delete key on your keyboard, you could directly boot up into the BIOS instead of pressing the delete key. So say suppose if your system is shut down and you want to directly go to the BIOS without wasting any time, just press that direct key and you are into the BIOS directly. Or you could do is just take a power switch and plug it into these two headers. You could short it and boom, directly into the BIOS. Cool feature, really very nice. So here are the front panel connectors, power connectors. Okay, so to the left of the direct key is the fast boot mode. Fast boot mode basically helps in booting into the OS faster than it normally does. What basically it does is it does not initializes all the USB ports. It's known as partial initialization. So in partial initialization, all the USB ports are not scanned, but whichever components are plugged into the USB port, only those excuse me, only those ports are scanned and booted up into the system. So fast boot comes in handy and even faster to boot into the OS. Fine, there are two USB 2.0 header, then this is the TP DB header and trusted platform module header if you are into it. Then optional fan header, optional temp measurement, then this is the SPDI F out, and this is the front panel HD audio out. So I'll tell you one thing, as you can see, it's been separated from the main board PCB. So what it exactly does is, this is basically a sound card which has been separated from the main board in order to reduce or eliminate the electromagnetic interference caused by this PCB. So you can get even more clear sound. There's a Supreme FX3 chip which ASUS claims they are using for better audio enhancement, and used steel plating over it, or it's a metal plate basically, to reduce the interference, electromagnetic interference basically. So yeah, it supports 7.1 audio, so you could use the 7.1 stereo speaker, 7.1 speakers for your onboard audio, from your onboard audio. Basically this onboard audio is kind of good, but not as good as dedicated sound card. But hey, no worries. If there is some person who wants to save money and still want to get a decent kind of sound quality, so yeah, here's the deal. Good, not bad sound quality at all. Fine. Then again, this is the MOSFET and VRM area where actually the power ripple correction and all those things take place. Here you could see is the north bridge area. This is the AM3 plus socket. These are the DIMMs. Here you can see is the EPU plus DG plus chip, which ASUS say helps in which controls, basically does not help, which controls the power delivery to the CPU and VRMs. Fine. Here you can see is the EZ plug. What it basically does is, say suppose you are using 3 graphic cards at once, so basically 3 GPUs should actually need that much of power. So what it does is, the motherboard cannot support so much of power delivery through these PCI Express slots. So you could just hook in a Molex connector over there, the Molex cable in there, so that it provides a good power delivery to the PCI Express slots and eventually does not bottleneck or say does not let any card run on it. But the dual GPU solution, or I mean, excuse me, 2 graphic cards wouldn't hurt. I mean, no need for plugging in there. But see, if you are using 3 GPUs, say 3-way Crosshair or 3-way SLI, so it's really very good, no doubt about it. So now I'm going to show you another image showing this the backside panel. But before that, let me show you one thing. Behind this ROG logo actually resides the chipset. The chipset meaning it's the south bridge. Fine. So now I'm going to change the image and show you what its backplate looks like. Yeah, there you go. So here is the PS2 connector, 2 USB 2.0, 1 SpeedF or the optical audio out, 2 and 2, 4 USB 3.0. Let me count these USB 2.0s. 1, 2, 3, 4, 5, 6, 7. So 7 USB 2.0 ports, 1 ROG connect or the link. Guys, this is the back panel of the motherboard. Here you can see is a single PS2 connector for old school overclockers. Then 1, 2, 3, 4, 5, 6, 7 USB 2.0 ports, then 3.0 ports, 4 3.0 ports, 1 optical audio out, 1 clear CMOS switch, 1 ROG link or ROG connect button, which I'll explain you later on. This is a ROG connect port. Then 2 eSATA/USB 2.0 ports, 1 Intel Gigabit Ethernet port, and here is the onboard audio out. So now what I will be going to do is, I'll stop the camera now, and then I'll be going to show you all the accessories which we get with the motherboard. Yeah guys, now we will open up the box and see what's in there. Basically you won't see the motherboard in there because I have already put it in my rig. So yeah, let's go ahead and open it up. First of all, have a look at the exteriors. You can pause the camera and have a look at it. I'll turn the box around. Anyways, you can also see the pictures of this motherboard. I've put up all those things onto the side. I'll put the link underneath. So this is the accessory box. What things you get in it? First is the user guide, the driver CD, one nice ROG logo in there. Yeah, really nice. Sweet, isn't it? This is the basically you could attach this, stick this to the cables so that you don't forget what your SSDs or HDDs are attached to and all. This is the quick start guide, and this is the C. Leave it. This is the nice looking do not disturb game door hanger. Very nice. The IO shield is inside again. This is the 3-way SLI bridge. Let me see. Yeah, the 2-way SLI bridge and the 2-way AMD's Crosshair bridge. Normally you get these with the GPUs. Nowadays you are getting this with the board as well. Only the higher end motherboards, I'm sorry. Anyways, these are the Q connectors, basically quick connectors for USB and the front panel. Fine. This is the ROG connect cable. I'm going to show you the ROG function later on. I'll tell you about it. I can't demonstrate it. Anyways, 6 SATA 3 cables, or SATA 6 gigabit per second, SATA or SATA, whatever you like to call it as. So that's it about the accessories. Now I'm again going to stop the camera and show you my test rig. Hello guys, this is my test rig. So I'm going to be showing you all the components which I've used in my test rig. So let's start up with the CPU. I'm using an AMD FX 8150, the Bulldozer CPU. For the RAM, I'm using G-Skill Ripjaws X 2133 MHz CL9 kit. It's a 8GB kit having two 4GB modules. I've set it in dual channel mode, obviously. The GPU I'm using is XFX Radeon HD 5970, the old school dual GPU king. Anyways, the motherboard, obviously it's the ASUS Crosshair 5 Formula Z. Power supply I'm using is Corsair's AX1200. I know it's an overkill, lot of people there will say, but still I'm a fan of overkill. Anyways, just kidding. The primary drive I'm using an SSD OCZ Vertex 2, and the backup drives, these are the Western Digital Black Caviar's SATA 6 gigabit per second. The case is the Corsair 600T case. Then you people might be noticing this cable in there. You might be figuring out what is it. Well, basically it's the cable, it's a simple power switch which I have actually attached to the direct key header. The direct key header which I showed you earlier. What basically it does is when I press this during the when the power is switched off, when I press this, I directly go to the BIOS, which helps me getting it into the BIOS directly without flashing or pressing the delete key every now and then. So yeah, I can effortlessly directly go to the BIOS, change whatever settings and go on there. So anyways, I'll be explaining it to you later on. It comes really very handy to the overclockers. So what I'm gonna do is now stop the camera and take you to the performance results, maximum overclocks for the CPU, for the RAM, for the FSB, and then I'll show you some performance benchmarks, not exactly the benchmarks but the snapshots of it which I've already tested. So anyways, now I'm going to stop the camera and move on to that part. Hello guys again. Now I'm going to be showing you all the performance results of what I have benched it earlier. So first I'm gonna start it with the stock. This is basically the snapshot of the stock clock speed of CPU, RAM, GPU and everything. So yeah, let's start it up. Basically FX8150, which is running at 3.6 GHz, which is default clock, and the maximum turbo is 4.2 GHz. So yeah, I have enabled the turbo core and I have benched it, leaving the turbo on. So everything was at the stock and I have benched it on that. So the board is Crosshair 5 Formula Z motherboard, obviously. For the RAM, it's the G-Skill Ripjaws X, which is running at its rated speed. Rated speed means the XMP. I have actually loaded up the XMP so that you can see here is 1070. That operates in a dual channel, and so the speed doubles. So what we basically say is 2133 or whatever that calculation goes up to. Anyways, the clock latencies are also stock 9, 11, 10, 28 to N. And the GPU, it's the Radeon 5970, so you can see 5900 series. It's an AMD GPU, previously owned up by ATI. Anyways, the GPU clock is at default 725 MHz on the core, and the memory is running at 1 GHz or 1000 MHz, whatever you like to call it as. And yeah, the ATI Crossfire, you could see, is because this GPU is a dual GPU having two GPUs on a same PCB sharing the same VRAM. So yeah, anyways, these are the stock settings. Now, what maximum overclock for the CPU I was able to get even after loading the XMP was 5.5 GHz, which is actually really a good, impressive overclock at such a low voltage. I mean just 1.4 volts, and I was able to cross 5.05, excuse me, 5 GHz. I was able to cross it. So basically the multiplier was set to 22, the bus speed was 229, and that's how I ended up getting 5.05. Anything above that wasn't able to get it so much of stable. So yeah, you could see 8 cores are enabled, all the 8 cores are enabled. Then the RAM is running at its rated stock frequency as well. The north bridge frequency, well, it went up to 25, 27. I've overclocked the north bridge as well. Basically I've overclocked the NB, not the CPU NB, excuse me, not the physical north bridge. So yeah, it went up. I mean, I set it from 2200 MHz to 25-27 MHz. Yeah. Then it's a ASUS Crosshair 5 Formula Z motherboard. Anyways, this is the maximum overclock for CPU. Now the maximum overclock for the memory. See, the core speed for the CPU, all the 8 cores enabled, and the voltage was set manually. This CPU is actually crazy. Really, I'm getting really surprised by this chip. Actually, doesn't run at so low voltage. Anyways, I have set the core speed near about to the stock, that is 3.6 gigahertz. Here you can see is 3581 megahertz, whatever. The HT link is at 2400 megahertz. The CPU north bridge frequency is at 2400 megahertz, and the RAM, really shocking, man, I did not overvolt it. I just changed the memory timings and I was able to get 2456 megahertz, or in a single channel it's 1228.1 megahertz. That's really boom. Nice kit, nice kit. Even the motherboard supports is very well. The default clock for support for the motherboard for the memory is 2400 megahertz. I was able to cross it, no, with no issues at all. I just went up a notch, CL9, so I've done it to CL10. The TRCD was at 11, so I went up to 12. Here it was 10 TRP, I went up to 11, and this was 28, I went up to 31. This was really stable. I've even primed it for a while, no issues at all. Every core, single core working, no blue screens. Anyways, the command rate was 2T. I don't know why CPU Z is not able to read it, but anyways, that must be some driver issue. Not the driver issue, this thing, software issue maybe. Anyways, now let's jump up to the maximum FSB which I was able to squeeze out. So you could see everything was pretty much low, and obviously it has to be because I'm trying to achieve the maximum FSB. Boom, the maximum FSB I have reached is 340, so that's too much at a standard stock cooling. I mean, yeah, the Noctua NHD14 helped it a bit because the 140mm fan which is squeezed in between actually passes up some air on the VRMs, so yeah, it does help a bit, but still no exotic cooling, and still I was able to get 340 FSB, so that's too much. My god, really I liked it. Now as far as the comparison goes, I've made some graphs. So what you can see, well, I'll just go to the graph images and I'll explain it to you very well. So yeah, this is the actual comparison between the stock and the overclocked. I'm sorry, I forgot to show you the settings which I've used for benching. Anyways, I'll show it to you now. Yeah, so I was able to stabilize my system pretty much on Prime 95. I've ran it for like 1-2 hours, super power ran without problem. Cinebench was able to run properly with the 8 cores enabled. Then again, sorry guys, the camera's battery ran out and I apologize for that. Anyways, I'm resuming it again. So I was going to show you the snapshot of the clocks which I use for benching. So the CPU core speed is at 4.8 gigahertz. The core voltage was 1.46 volt. Then the bus speed was 229, multiplier 21 obviously. The HT link was pretty much at 2300. Same must be for the north bridge. No, the north bridge is overclocked at 2527. The RAM was at its rated speed, and the clock latencies were pretty much the same. I mean, you could say the XMP. I have already loaded the XMP, just change the core clock and the north bridge frequency. Basically I've changed the CPU NB, which is the IMC. Then again the GPU was at the stock speeds, 725 MHz on the GPU clock, and the memory was running at 1 gigahertz or 1000 megahertz, whatever you like to call it as. The Crosshair was enabled, so it's a dual GPU card. Anyways, I've told it to you before. So now I'll be showing you the comparison chart. The first benchmark is 3D Mark 11. Anyways, at the stock it's 6926, and at the overclock it went up to 7420. The next is 3D Mark Vantage. Stock is at 22329, and on the overclocked, performance was like, the scores went up to 25538. Aida 64 latency benchmark. Obviously the latency should drop as you overclock. So the stock, as you can see, it's at 59.1 nanoseconds. On the overclock it came down to 55.4. For the L1 cache memory, stock was at 1 nanosecond, overclocked 0.8. For the L2, the stock was at 10.2 nanoseconds, and for the overclock it came down to 8.3 seconds. Nanoseconds, I'm sorry, excuse me. L3 cache excuse me, L3 cache was for the stock it was like 32.8 nanoseconds, and for the overclocked frequencies it came down to 28.7 nanoseconds. Aida 64 CPU L1 cache benchmark. So the reads were pretty much good, write were good, copy were good. So basically there is a lot improvement in the benchmark for the overclock side. Anyways, I'm not going to read out these results. You can just pause your camera, or you could just click the link underneath and you could go to the forum page and you could see the review, and you could just have a glance at those benchmarks. So yeah, I'll be just showing you the snapshots. You could pause it wherever you want. Memory benchmark, Cinebench, PC mark, Unigine Valley benchmark, 3D Mark 11 performance. So yeah, we are back from where we were. So back to where we were. So yeah, the benchmarking is done. Now what I'm going to do is I'll stop the camera and take you to the conclusion. So here we are, finally into the conclusion. On behalf of Team OCF, I would like to give this board a solid 9 on 10. I've liked many features about it, and yeah, this board is really epic. First of all, the overclocks. This board is really rock solid stable on overclocks. Especially on the higher overclocks, this board doesn't compromise the stability. So I really like this board for as an overclocker. I'm not much of a gamer, but the gamers can rejoice now. The Nvidia fanboys can rejoice. Like they have already provided the by default support for AMD's Crosshair as well as Nvidia's SLI. So yeah, for the 990FX chipset boards, nowadays from now onwards you will get the official support for SLI and Crosshair. Anyways, the Crosshair or SLI doesn't matter much to the chipset, but you just have to use a Crosshair or the SLI bridge in there, which will connect your two cards. So it's a physical connection more than regarding the chipset. Anyways, many features I've liked, like the go to BIOS button or the direct key, what ASUS call it as. That's really good feature, saves a lot of time and really helps in improving the life of keyboards delete key. Just kidding. But the thing is, like, you don't have to press the delete key every now and then to go into the BIOS. So it really helps overclockers a lot. There's an onboard switch where the test bench users can basically just press that button rather than connecting the power switch or something like to the header which they have given. Or people like me who use the cases can use that power switch by connecting it to the header on the motherboard, and I could just press it and boom, I will be into the BIOS. Second thing, the ROG Connect. The ROG Connect, I really like it, man. It's really nice. You could just connect one end of the cable to the laptop, install the software utility for the ROG Connect, and install the ROG Connect software utility for the client as this CPU. Then you could just hook that other end of the cable to the rig, I mean to the back of the motherboard, where you could see the white colored USB port. That's the ROG Connect port. So you could control the parameters and tweak those parameters in the real time, and without much worrying about the stability. It does create a bit of a glitch, but it doesn't hamper the stability. The system runs stable very well. You could control the voltages, the base clock, many other things. So hats off to that ROG Connect. Really good feature. Again, the temperatures of the board are really very stable and does not cross much. Like, I haven't seen any temperatures for the north bridge as such for about, say, the maximum which I saw was 55. That was pretty much at higher overclock. I was benching the rig at 4.8 gigahertz. So at that time the voltages were high, and obviously the power delivery will increase, and eventually the VRM temperatures will go up. The same kind of heat pipe is connected over the north bridge as well, so eventually the north bridge temperature will increase as well. So anyways, the board is really rock solid. The VRMs are really very good, doing a very good job on it. Then again, some features in the BIOS, like the DG Plus power control thing, which has all those parameters related to stabilizing the overclocks, the CPU current capability, the CPU LLC, the load line calibration, obviously, which doesn't allow the CPU V-core to drop and create instability in the overclocks. So yeah, the CPU current capability, it actually does limit the frequency and the voltage channel. Basically, not the channel, what you could say is, it basically is a range in which you could set the voltages and the frequencies for the CPU. Anyways, that feature helps a lot. I have set it to maximum at 140%. So depending upon the how much percent you would like for the CPU current capability to be, you could overclock higher. Anyways, you could set your power phases manually. You could set it to full phase, or you could set the power phase frequency, CPU phase frequency, to manual. I'm not getting it, but you could just have a look at DigiPower snapshot, which I'm going to post it in the review, the written review at my forums. So and the onboard audio solution on this board is good as well. Really very nice onboard solution. Many people anyways are going to end up buying a dedicated sound card, but hey, if you want to save your money, you just use the onboard audio solution. It will be fine for gaming and all. That is pretty much fine. But if you are kind of a sound freak and you need all those highs and lower frequencies to be more of an accurate, so you will obviously end up buying a dedicated that dedicated sound card. So yeah, that is good as well. Then on the networking side, I mean they have provided Intel Gigabit Ethernet port, so that's good as well. Helps in reducing the latencies and high transfer rates, good bandwidth and all those kind of cool stuff. So also the OC profiles, I can store my overclocking profiles in there and will not much worry about again screwing up the overclocks, or if I just accidentally tweak some parameter in a wrong way, and if I am not able to post up into my system, I will just clear my CMOS, go back to the BIOS, load the OC profile, and I will be fine. So yeah, OC profile is really a very good helping feature. Obviously it's the ROG board, so no worries about that. You will get all those features in each and every ROG motherboard. So yeah, I have spoken a lot, but the thing is, this motherboard is really very good. Hats off to ASUS, and really like this board. Since this is my first video review, I apologize for my mistakes in advance, and yeah, hopefully you guys must have enjoyed my review. Maybe not. Anyways, I have also posted a written review which I will be posting a link underneath, so you could check out my written review over there. And obviously I have not covered each and every snapshot, so you could just check it over there on the forums, on the review, on the review, and you could just have a glance at it. So yeah, this is Prathamesh Patil once again from team OCF. So I'll be hopefully making some new reviews about motherboards, GPUs, CPUs and whatnot, all these cool stuff all you people may already know. So yeah, thank you. This is Prathamesh Patil signing off. Bye.